Alright, hello my wonderful students. This is part 3 of Foldable number 1. For this one we're going to be grabbing what looks like a triangle again because we have 3 points. So let's go ahead and get started. So we have our first point here, we have a triangle JKL. Our first point is J, which is at 2, 5. 2, 5. This is our J point at 2, 5. We have our K, which is at 2, negative 3. 2, 1, 2, 3. This is our K. 2, negative 3. And then we have our L. Oop, forgot the parentheses there. Our L, which is at negative 2, 1. Negative 2 and 1. L, negative 2 and 1. Then we're going to go ahead and connect these dots. We'll do this one in blue. Alright, so for this one we need to find our height, or we can, well, we're going to use this one as the base here, but we need to go ahead and find that first. So for doing that we can actually just take our, since these are the same here, we can just take the number that's here and subtract them, or yeah, subtract them. So we have 5 minus a negative 3, and that would give us an 8. And then we need to find the distance from, luckily this is on a point, but we see this is on negative 2 and these are both at 2, so we know the distance from here to this line is going to be 4. So if we look at it from here to that 1, this height is going to be 4. So we can find our area already. Our area is going to be equal to 1/2 base times height. Once again, our base was 8, so we have 1/2 times 8, and our height was 4. I'm going to go ahead and multiply the 1/2 times the 8 and get 4. 4 times 4 would be 16, so our area is equal to 16. So for this one's a little bit different. We do have well, we have an isosceles triangle, because if we notice here, the midpoint here would be where we go, because if we're going from, let's go from here to here and from here to here to positive 1, from 5 minus 1 would be 4, and 1 minus a negative 3 would also be 4. So this actually splits in the middle of 4 and 4, which is good. That means we only have to find the distance of this one or this one, and it's the same. So we're going to go ahead and do that by using our a squared plus b squared equals c squared. Once again, we said this was our, well, it doesn't really matter. This is going to be a hypotenuse here, so it's going to be AB or AB, which is both 4, so it doesn't really matter. So we have our a squared plus b squared equals c squared. And once again, we're going to use our 4 and 4. So 4 squared plus 4 squared equals c squared. I was going to say 16 squared. So we have 16 plus 16, which is going to be 32 equals c squared. Take the square root of both sides, and we get that c is going to equal to, when we break this down, it's going to be 4 radical 2. Because it'd be 16 times 2, the square root of 16 is 4, and then left over would be 2. Alright, so now we have the length. This is 4 radical 2. So that means this is also 4 radical 2. Now we can find our perimeter. And our perimeter, remember, is equal to all sides, right? So we have 8 plus 4 radical 2 plus 4 radical 2. We're going to leave it like that as radical 2. We're not going to go ahead and multiply it through. So we're going to have is equal to 8 plus 8 radical 2. And that's going to be our perimeter. We can leave it like this.